And welcome back, everybody. We are in Chapter 3, Part 2. We're going to be talking about variation. And before we jump into that, we're going to start with a definition of range. And what we mean by that in a statistics class is this is the max value minus the minimum value. This is the range. So the range for this one, the max is 26, the minimum is 22, giving me a 4. Once again, these actually all have the same range, 26 minus 22 to give me 4. We'll come back to that. That's going to be useful here in just a moment. As I said before, the mean is hands down the most important parameter that we're going to be dealing with. The standard deviation is the second most important. So this is the standard deviation. And I want to talk just a little bit about what I mean by that. The standard deviation is basically if you take the all of the data and you find the mean, the average, then what's going to happen after you find the mean is what's the average distance that all the data are from the mean? Let me give you an example of what I mean. Let's say I give it a test, and 70% is the mean, the average score on the test. If the standard deviation is really small, that means that the scores were 69, 72, 70, 71, 68, and so all the scores are very, very close to the mean. A large standard deviation would be the mean is still 70, but the scores were 95, 12, and so on. So really far away from that would be a large standard deviation. When we're dealing with a sample standard deviation, we use the letter S, and I put a little extra tick on mine because my S's look like 5s, unfortunately. And the formula that we get for this, it's a big one. This is the summation again of x minus x bar squared all over n minus 1. So this is our standard deviation. And let's talk about some properties of the standard deviation. The good news is the calculator will do all of this, so don't let this formula scare you too badly. We have the big guns here, so we'll come back to that. So the standard deviation is a measure of how much values deviate away from the mean. The value of the standard deviation S is not usually, always positive. And that's by nature of the formula. You can see the square root, the result of a square root is always positive when we're dealing with real numbers. The unit of the standard deviation S is the same as the unit of the original data values. What that means is, let's say that the data values are all in inches. So I'm measuring, again, heights of my students. I'm measuring them in inches. Well, when we find the standard deviation, the unit on that is also inches. So that's all that means. The sample standard deviation S is what's called and I'm going to write this below here, a biased estimator. Of the population standard deviation, meaning the sample standard deviation, when I find its standard deviation, it's not going to be exactly the same as the population standard deviation, which is always what we really want. It's going to be a biased estimator. So it's going to be biased, meaning it's based on the sample that was actually taken. And we, to do the standard deviation of these, are going to use 1 var stats. I'm going to show you where that is. First thing I need for you to do is enter into your list here. I've pre-done that. So here's the first list, second list, and third list. You may need to pause the video to throw those in, and you don't need to use list 1, 2, and 3. You can use them all in list 1 one at a time. But I want to show you where to find 1 var stats. So I'm going to hit stat, and I'm going to go to calculate, and it's the first one, 1 var stats. Now there's 2 different interfaces with this. The newer calculators have it set up like this, And so I find L1, so this is going to be my L1. And remember, L1 is above the number 1. Mine's blue, so I have to hit the blue button first to change it to L1. And then I hit calculate. Now, if you don't have this interface like this, what's going to happen when you hit one var stats, you saw it real quick, it was a line, and then you would just put L1 next to it. And our standard deviation is right there. It's the S of x, 1.67. So S here. Again, you can see I got that there. It's not the sigma. And I'll talk about what sigma is here in just a moment. So I'm going to turn off this interface to show the other calculators what they do. So I'm going to hit stat, calculate one var stats, and you can see if you have an older calculator like a TI-83, it's going to do this, and then I just tell it, in this case L2 for the second list, second L2, and L2 comes right up. Hit enter, and there it is, 1.70 looks like. Now you should be doing this yourself with your calculator now. Don't wait and try to practice later. You should be doing it with me during the video. In my third list, mine's an L3, so my standard deviation that I got is 1.58. 1.58. It's the S. All right, we are now to the range rule of thumb. So for the minimum usual value, it's going to be the mean minus 2 standard deviations. And the max usual value is going to be the mean plus 2 standard deviations. We'll learn why it's 2 standard deviations a little bit today, but when we get to chapter 5 and 6, we'll be able to actually calculate that and view that. And then if we need to roughly estimate the standard deviation, we can actually just take the range and divide it by 4. If you remember, the range is the max minus the min. We can write that in there. So it's the max minus the min divided by 4. And I'll show you where the 4 comes from in just a minute. It's always going to be 4. You don't have to calculate that. And let me give some... let me define this notation down here before we do these 2 examples. The sample standard deviation is the letter S. Sample variance is S squared. The population standard deviation is lowercase sigma. And the population variance is the sigma squared. Meaning it's this formula without the square root for the variance. All right. So we have a mean of 24 chips. By the way, these are chocolate chips on a chocolate chip cookie. The context was lost by this version of it. So that's what we mean by chips. And the standard deviation is 2.6 chips. We're going to use the range rule of thumb, that's this here, to find the minimum and maximum usual number of chips. So for the min, that's going to be our mean, which is 24, minus 2 times the standard deviation, which is 2.6. So 24 minus 2 times 2.6, 18.8. The max is going to be 24 plus 2 standard deviations. 29.2. And what we mean by this is if I had this chocolate chip cookie and there were 23 chocolate chips on it, that would be totally usual. That would be totally normal. Nothing wrong with that. Now, if I had the same cookie and there were 32 chips on it, or even more, 30 chips on it, that's bigger than my max. So that is unusual. So in this case, the 30 chips is unusual, because it's bigger than our max. And if we had one where the chocolate chip only had 15 chips on it, that would be unusual as well, because that's below the 18.8 or the 19. Now we're going to do the same thing, but now we're going to use our rough estimation if we have the min and max. So this is our standard deviation is about 30 minus 19 divided by 4. And once again, I will show you in a minute where the 4 comes from. Notice I did 30 minus 19. I'm going to hit equals now. Don't just hit divided by 4. You'll get the wrong answer. So, oops, 11. Forgot to divide it by 4. So an approximation is 2.75 of the standard deviation. And you can see it's relatively close. All right. So we are now on to the empirical rule for data with a bell-shaped distribution. Now, what we want to view with this bell curve here is the area underneath it. We're going to come back to it. Don't worry about it. But we're going to learn how to find the area here. Again, the calculator does it all. It's not a problem. Here's my mean, and here's one standard deviation out. The area that's underneath this is a total of 68% of all of the data. And later we'll learn why that's relevant, why that's even important. Now, if I go 2 standard deviations out, that captures 95% of all of the data. That's why we go 4. 1, 2, 3, 4. That's why we divide by 4 with the rough estimation of the standard deviation. That captures 95% of the information that we need. Anything outside of that is considered unusual. So we could even go 3 standard deviations out, which we don't do that, but we could, and that's going to give us the 99.7%. Now, these percents, we will learn how to find ourselves, and these are rough approximations as well. You'll want to hang on to that. This is going to be quite helpful. All right, so we are to the practice. IQ scores have a bell-shaped distribution with a mean of 100 and standard deviation of 15. What percentages of IQ scores are between 70 and 130? So I'm going to do this. So here is the mean, which is 100. And if I go up a standard deviation, that's 115. If I go down a standard deviation, that's 85. If I go up 2 standard deviations, that's going to be 130. Down 2 standard deviations, that brings me to 70. Now, how many standard deviations did I go from the mean? Well, I'm going 2 standard deviations away. 1, 2. How much information does that capture? 95%. Once again, we started here at the mean. When a standard deviation out, and between 70 and 130, 70 and 130, that's 2 standard deviations out. That captures 95% of the information. Once again, 2 standard deviations out gives us 95%. We are not going to be doing Cherepov's theorem in this class, and that actually ends the